Okay, so this is a different version of dealing with a blog. And I wanted to go through this briefly. This is mostly for my class, but anybody out there in internet land can join in. Jesse Jenkins, a former student of mine now at MIT, and me, both and professor at the University of Oregon, are publishing a small blog article about the way at which the rate of deposition of CO2 in the atmosphere is actually accelerating, and this is really not very well reported yet in the mainstream media. This all started in February of 2013 when I was in class and somebody asked me a question what the current CO2 level was, and so I immediately pulled out this diagram and looked at it and went, holy crap. And the holy crap moment is because I can do arithmetic in my head pretty fast, even though I can't really talk, and realized the difference between February 2013 and February 2012 was 3.26 parts per million. And that's a huge jump. Now, here we are today, and it's of April. May date is not in yet, and we're cruising toward breaking 400, so we should all have a party about that. But here the differential is now 1.9 instead of 3.6. That's more normal. Nonetheless, this 3.26 is quite alarming. So I set around to go back in the past, and I just looked at the 60s first. We'll see later data in a while. Measuring the individual monthly anomalies on an annual basis. In other words, 1961 versus 1960, 1962 versus 1961. And clearly, none of them are above 3. And then I did the same thing in the recent past from January 2004 to December 2012. And you see it's very infrequent that you get above 3 for one of these indices. So the February 2013 position was rather remarkable. Now, where this all comes into play is the following. This figure. So let's suppose that we declare 500 parts per million as some kind of point of no return. If we get there, it'll just suck and it'll be hard to go back. And so what this diagram shows is if I just take the annual CO2 buildup in the 60s, 70s, and 80s until now and calculate based on that rate from that time, how long will it take to get to 500 parts per million? So in the 60s, well, we had 224 years ahead of us, so why do anything? By the 70s, that had declined almost in half, down to about 128 years, but still, that's a long time away. And then things kind of stabilize in terms of the rates and the projections in the 80s and 90s, such that we have about 95 years left, whether you're in the 80s or in the 90s. If you look at the decade of the 2000s, this 500 part per million horizon now is only 60 years away. That's still a long time away. But if I calculate the rates just based on 2010 until now, including up until April 2013, that time scale is now 37 years. That's short. We're running out of time at an accelerating rate. And this acceleration can be also seen down here in the Arctic sea ice loss trajectory. This is just a fit to the nonlinear part that kicks in around 2005. It's a statistically valid fit. The fit might change depending on how you weight it. But nonetheless, it predicts that sometime, here it's 2015 formally, I don't think anybody believes that, but certainly in the framework 2020 to 2025, it's very likely that on September 15th, there will be no more ice at the North Pole. It will all be gone, 0 extent. Book your cruise line, visit Santa now, take your children. When you get to Santa's home, which is now underwater, how do you respond to the question your children are going to ask you? Why did you melt Santa's home?